Hello everyone. Through the study of the previous chapters, you must have a certain understanding of the normal operation and operation of the power grid. On this basis, we further study the comprehensive regulation and control of the power system. The comprehensive regulation and control of the power system includes the following contents: the paralleling or decoupling, and the loop closing or loop opening of the power system. The impact of synchronous paralleling or not of the power system on the generator and the system. The case study of the comprehensive regulation and control of the power grid is a relatively complex operation of the power grid, which contains many problems to be considered and has a great impact on the power grid. Next, we are going to learn the paralleling or decoupling of the power system and the closing or opening of the loop network. Let's learn it together. We have heard of the paralleling and decoupling of generators, so what is that? Putting an asynchronous generator into the power grid to participate in the parallel operation, or paralleling the two power grids that operate out of sync into one power grid operation, is called paralleling, and the corresponding operation is called the paralleling operation. An operating power grid is divided into two independently operating power grids, which is called decoupling, and the corresponding operation is called decoupling operation. The paralleling of two power systems is achieved by closing circuit breakers on both sides, which is called the synchronous paralleling. The synchronous paralleling requires the following for conditions to be met simultaneously. 1. The phase sequence on both sides of the parallel circuit breaker is the same. 2. The phases on both sides of the parallel circuit breaker are equal. 3. The frequencies on both sides of the parallel circuit breaker are equal. 4. The voltage on both sides of the parallel circuit breaker is equal. You should remember the conditions for the synchronous paralleling of the power system. So, what are the conditions for the decoupling of the power system? When decoupling, adjust the active power of the decoupling point to near zero, and the current to the minimum. After decoupling, the frequency, voltage, and backup capacity of the two systems remain within the specified range. It should be noted that forcibly decoupling the system will have adverse effects on the generator and system. Let's take a look at an example of the paralleling and decoupling of the system, as shown in the figure. The small system and the large system are connected through the of line. Due to the function of the of tie line, the system can be parallelized and decoupled. Let's first achieve the paralleling of the system, assuming that the circuit breakers on both sides of the of tie line are in the open position. The first step is to close the circuit breaker on the large system side of the of tie line, and the second step is to close the circuit breaker on the small system side of the of tie line at the same time. So far, the two systems are paralleled to form a larger system. In the case of paralleling, the decoupling of the system is easy to master. First, adjust the active power of the of tie line to close to zero, then disconnect the circuit breaker on the small system side, and finally disconnect the circuit breaker on the large system side. So the system is decoupled into two systems. This is the case with the paralleling and decoupling of the system. I hope you can focus on master loop this. Now, let's learn what the loop network is. A loop network refers to a loop formed by directly connecting the lines operating at the same voltage level, and an electromagnetic loop network refers to a loop formed by connecting the lines operating at different voltage levels through the electromagnetic circuit of a transformer in order to adjust the needs of the power flow. The loop network sets up a disconnect point, closes the disconnect point, and the circuit breaker can realize the closing of the loop network. The closing of the loop net should be paid attention to. The phase should be consistent. After closing the loop, the components in the loop network are not overloaded. The voltage at each point should not exceed the specified value. The relay protection and safety automatic device should be adapted to the operation mode of the loop network. Stable compliance with specified requirements. The opening of the loop network can adjust the operation mode of the system. Before opening the loop, the power flow at the opening point should be checked and adjusted to ensure that the power flow changes of each component after loop opening do not exceed the limits of system stability, relay protection, and equipment capacity. The voltage changes at each node should not exceed the specified range. Next, let's learn the meaning of the loop network and the operation of loop opening through examples. The power flow diagram of Ganzhou power system is shown in the figure. The white line represents the 220 kV line. The red line represents the 110 kV line. The rectangular block represents the switch. The solid block represents the switch in the closed position. And the hollow block represents the switch in the open position. The blue line is marked in the figure, and the white lines are connected to form a closed loop, which is the 220 kV ring network. Please find a 110 kV ring network. Next, let's briefly learn the operation of opening the loop. According to the power flow analysis, after unlocking the loop, to ensure the normal operation of the system, we choose to open the loop at the hugging transformer 215 switch. At this time, the dispatching remote control will disconnect the hugging transformer 215 switch, thus achieving the unlocking of the loop network. Boys and girls, the content of this class describes the paralleling or decoupling and the loop closing or loop opening of the power system. Please think about this. 1. The basic operation steps of the paralleling and decoupling of the system. 2. The meaning of the loop network. That's all for this lesson. Thank you.